Okay, in this video, I'm going to go through the extra practice if you chose to do it. I kind of streamlined and found my molar masses that I'd need ahead of time so that you don't have to wait for me to figure them out. So the first problem is asking to convert molecules to liters. And I know that that is a two-step process. I have to go from molecules to moles and then moles to liters. And so two conversion factors, 1 mole is equal to 6.022 times 10 to the 23rd molecules. And then the second one is 1 mole is equal to 22.4 liters. And we're talking about ammonium or ammonia and H4. I will fix these subscripts. So I put what I know in the first box. That is the 9.734 times 10 to the 23rd molecules. I'm going to run out of space. NH4. I want to get rid of molecules, NH4, and that's going to give me moles, NH4. 1 mole is equal to the 6.022 times 10 to the 23rd. Sorry, I didn't leave you a ton of space. And then I want to get rid of moles and get, liters, not grams. And so 1 mole of ammonia is equal to 22.4 liters of ammonium. And so then I plug it into my calculator. 9.73 using the EE button. Sorry, 734. 9.734 EE to the 23rd times 1 times 22.4. And then I divide by what's on the bottom, 6.022 EE 23. And then I would divide by 1 again, and I get 36.207. I look at my sig figs. It looks like I'm going to be rounding to 3 sig figs. So 36.2 liters of ammonium. And that's my answer. If I look at the next one, I want to go from moles to grams. Well, that is a one-step path. So 1 mole of iron 3 bromide is going to be equal to 295.55 grams of iron 3 bromide. Then I plug my information into my frame. So I have 8 moles of iron 3 bromide. I want to get rid of moles of, I keep not leaving enough space, 2 grams of iron 3 bromide. And that is 1 mole is equal to 295.55 grams. Plug that into my calculator. So 8 times 295.55. I get 2,364.4 grams. I look at my sig figs. I only have 1 sig fig, and so that is going to be 2,000 grams of iron 3 bromide. If I look at the next one, I want to go from liters to moles. That is a one-step path. So 1 mole of any gas is equal to 22.4 liters of any gas at standard temperature and pressure. I put in the number I'm given, 985 liters. I want to get rid of liters. And I want moles. I plug in my numbers from my conversion factor. And then I multiply across the top, divide by what's on the bottom. And so that is 985 times 1 divided by 22.4. I get 43.973, blah, blah, blah. I look at my sig figs. I have 3 here. I have 3 here. So my answer is going to have 3 sig figs. So that means I'm going to cut it off at the 9. 7 tells the 9 to go up. So this is going to be 44.0 moles of HCl. The next one, I want to convert 1,000 grams of dinitrogen pentoxide to molecules. And so here I'm going to have to use 2 steps. The first step is my formula mass, which I already figured out is 108.02 grams of dinitrogen pentoxide is equal to 1 mole. And then I also know that 1 mole is equal to 6.022 times 10 to the 23rd molecules of dinitrogen pentoxide. And so I plug these into my framework. I want to get rid of grams, so grams goes on the bottom. And if I look at the conversion factor, that's going to give me moles. And then I plug in my numbers. The next thing I need to do is get rid of my moles. And I want molecules. And I have to plug in Avogadro's number here. So 6.022 times 10 to the 23rd. Multiply across the top, divide by what's on the bottom. And so I have 1,000 times 6.022 EE23 divided by 108.02 divided by 1. And I get 5.5748 blah, 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 times 10 to the 24th. I look at sig figs. Here is 1 sig fig, 5 sig figs, 4 sig figs. So I have to round it to 1 sig fig. And so 5 tells the 5 to go up because due to statistical rounding, if it's odd and a 5 is dictating the rounding, it goes up. And so I'm going to have 6 times 10 to the 24th molecules of dinitrogen pentoxide. And that's my answer. Okay, 2 more to go. Okay, here I have a lot of atoms of sodium, and I want to go to moles. So the only conversion factor I need is 1 mole is equal to 6.022 times 10 to the 23rd atoms. Remember, it's atoms if it's an element, molecules if it's a compound. I put what I know in the first frame. So I have 123, 4, 5, 6, 7, 8, 9, 0, 0, 0, 0, 0, 0 molecules of sodium. I want to get rid of molecules of sodium and get moles of sodium. So I will use Avogadro's number as a conversion factor. I don't know if I can fit this into my calculator. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 0, 0, 0, 0, 0 times 1 divided by 6.02 EE23. And I get a very small number. 2.050 times 10 to the negative 10th. If I look, I have 9 sig figs here. I have 4 sig figs here. So I'm going to cut this off at 4 sig figs. 7 tells the 0 to go up. So it's 2.051 times 10 to the negative 10th atoms. Not atoms, moles, sorry. Moles of sodium. If I look at the last one, I have 500 grams of this hydrocarbon. I want to go to moles. And so I know that 1 mole is equal to the formula mass, which happens to be 86.14 grams. I put what I have in the first frame, 500 grams of C6H14. I want to get rid of grams. And I want moles. 1 mole is equal to 86.14. Multiply across the top, divide by what's on the bottom. So 500 times 1 divided by 86.14, and I get 5.8045, and so on. I look at sig figs. This has 3 sig figs because of the decimal. This has 4. So I'm going to cut it off at 3 sig figs. That means I'm going to have 5.80 moles of this compound. If you have any questions, don't hesitate to send me an email or visit my office hours. Until next time.